Electrolysis. Electrolysis is the decomposition of an ionic or polar covalent compound by passing electricity through its molten or aqueous state. A chemical change takes place. For the process of electrolysis, some basic components are needed. First one is an electrolyte, which is taken in molten or aqueous state, two metal rods or graphite rods which act as electrode, a source of current which is generally a battery. The electrode which is connected to the positive terminal of the battery is called anode, and the one which is connected to the negative terminal of the battery is called cathode. On passing electric current, the ions of the electrolyte move towards opposite electrodes and get discharged there. The ions present in the electrolyte are cations and anions. Cations move towards cathode and anions move towards anode because opposite charges attract each other. At anode, oxidation takes place, and at cathode, reduction of the process takes place. If more than one type of ions are present in the electrolytic solution, then which ion will get discharged first? This is decided according to the preferential discharge of ions. So selection of ions for the discharge at their respective electrodes from the electrolytic solution is called selective discharge or preferential discharge of ions. This preferential discharge of ions depends upon three main factors. First is the position of ion in electrochemical series. Second is the concentration of ions, and third is the nature of electrodes, especially anode, because if it is active, it will participate. First factor is the position of the ion in the electrochemical series. Lower the position in electrochemical series, easier is the discharge. It means the ion which has a lower position in electrochemical series will get discharged first as compared to the other one which is above it. And this rule is for cation as well as anions. Second is the concentration of the aqueous solution. Those ions which have a higher concentration in the solution will get discharged first as compared to the ions which have a lesser concentration. Electrolysis of molten lead bromide. Here, lead bromide in its molten state acts as an electrolyte. The two electrodes used are graphite rods. These graphite rods are connected to the source of current. Electrolyte dissociates into its ions, lead ions and bromide ions. When current is passed through it, lead ions will move towards cathode. They get discharged and get deposited in the form of grey metal at the bottom of it. Bromide ions move towards anode. They lose their electrons to form bromine atoms. Two bromine atoms combine together to form reddish brown fumes of Br2 or bromine. Electrolysis of acidulated water. Acidulated water means water containing a few drops of sulfuric acid. Sulfuric acid is added to make water a good conductor of electricity. This process is performed in a special type of apparatus which is called Hofmann voltmeter. In this apparatus, there are three interconnected tubes. Through the middle tube, acidulated water is introduced inside and electrodes are connected on the outer two tubes. Platinum acts as electrodes here. Cathode and anode both are made up of platinum foil. When we pass current through it, its ions will move towards opposite electrodes. So, sulfuric acid and water, they get dissociated into their ions. We get hydrogen ions, sulfate ions and hydroxyl ions. Then at cathode, hydrogen ions get discharged and hydrogen gas is liberated at cathode. As per the selective discharge of ions, at anode, hydroxyl ions will get discharged. They lose their electron and form OH. 4 OH groups combine to form water molecules and oxygen gas is liberated. The overall reaction is water dissociates to form hydrogen and oxygen gas. Electrolysis of copper sulfate solution using copper anode. Here copper anode is active anode. A solution of copper sulfate containing a few drops of sulfuric acid acts as electrolyte, and the components of electrolyte dissociate into their ions. So we have copper ions, sulfate ions, hydrogen ions and hydroxyl ions in the solution. On passing electricity, copper moves towards cathode to form copper metal, and at anode, copper from the electrode comes into the solution to liberate copper ions. Because copper is active, so it participates in the reaction. So size of anode gradually decreases and size of cathode gradually increases. The concentration of the solution remains